Here we go. Tired. Let's get it going. Wake it up. Wake it up. Wake it up. Alright. F of x is x squared. We got our 5 dots. Right? So these 5 dots are made up of x and y, which y is f of x. Okay? And they're made up when x is 2, 1, 0, -1, and -2, right? And so then what we're going to do is we're going to figure out what y is. Well, 2 squared is 4. 1 squared is 1. 0 squared is 0. -1 squared is 1. -2 squared is 4. And that's where we got our points. Right? Yes. Okay. Now we're going to take a look at this guy. Now we should know something right away. We should know something right away. We should know that it's smiling or frowning, right? Which one is it? Frowning. This guy is frowning. Why? Why, Ryan? Because it's negative. That's right. Very good. Okay? Because it is negative, it is frowning. That means this thing's going to flip. Okay? We should also know that there's a big difference between -20 on the outside of x squared and 1/3 on the inside of the square. See the difference, right? So this 1/3 is going to get multiplied, right? It's going to get squared. But this 20 doesn't get squared. That's the difference. So the 20 is directly affecting the function. It's on the outside. When it's on the outside, what do we call that? When it's on the outside, right? Is that vertical or horizontal? When it's on the outside. Vertical, right? Outside is vertical, right? Inside, horizontal. Outside, vertical. Okay? When we're talking about multiplying, are we talking about stretching, compression, or are we talking about shifting? Yes. When we're talking about multiplying, stretch, good. When we're talking about multiplying by 20, we're talking about a stretch, right? Because why? Because it's bigger than 1. Good. It's bigger than 1. So this is a vertical stretch. Right? Okay. What's the factor? By a factor of -20, right? So think about that, guys. This can be really easy or this can be really hard. Which one do you want? Oh, okay. Let's do easy. All right. So we're taking that f of x and we're going to find h of x. Right? By doing what to f of x? By multiplying -20. By multiplying -20. So what's -20 times 4? Come on. -80. What's -20 times 1? What's -20 times 0? What's -20 times 1? What's -20 times 4? Right? That ain't that hard, right? Could I graph that? Sure I could. Do I want to graph it on this plane? I don't think so. I think I want to make another existence, right? So what I'm going to do, if I need to fit 80 on here, well, fitting 1, that's just 1, 2, 3, 1, 2, 3, right? Right? But what about, I don't want to go to freaking 80. 80? That's a long ways. So how can I make it go to 80, but in a smaller area? By tens. Yeah. So I still have the same amount. 1, 2, 3, 4, 5, 6, 7, 8, right? And that's 80. 1, 2, 3, 4, 5, 6, 7, 8. And that's 80. And that's 20. Negative. Right? Okay. Let's graph it. See what happens. Okay? I'll graph it with this nice, beautiful orange. At 0, it's at 0. Okay, that was easy. Woo! At 1, it was at negative 20, right? At both negative 1 and at positive 1. Is that true? And at 2, it was at negative 80. Is that correct? Now I see that it flipped, but it doesn't look like I stretched it that much. Does it? It doesn't look stretched, does it? So let's take a look again. Let's look one more time at this function. Remember, that function, at 1, it was at what? At 1, it was at 1, right? Where's 1 at from here? Isn't this like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? Something like that, right? So 1 is way down there, right? So 1 is down here. Right? And then where's, on 2 it was at 4. How far is 4? Is that about halfway? Right? And so you see what's happening here? Does that look like it was flipped and stretched now? Yeah, by a lot, huh? It's a lot stretched. Okay? Does that make sense to you? Yeah? Woohoo! Better than third. Okay. Alright, so are we sure? Does it make sense to you? Okay. Okay. Boylan? Still here? Confused on this? Yeah, it is confusing. I was waiting for somebody to tell me the truth, okay? Because it is confusing. It's like, whoa, 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 how does that happen? Why is this the same as this, right? This is how people lie with statistics, okay? This is how you lie with statistics. If let's just say that the Republican government doesn't want people to really see that jobs are going down at a significant rate. Okay? So if there is a graph, right? And that graph looks like this. That looks like it's going down, right? Well, let's talk about from your point of view. That looks like it's going down from left to right, right? So if I made and stretched it out, if I vertically stretched or horizontally stretched, right? What's going to happen to that graph? It's going to flatten out, won't it? And when it flattens out, it doesn't look like it's going down by that much, does it? Okay? That's an easy way to show graphs to people who don't understand math and go, look, come on, that's fake news. Look at this. Look at this. This is our chart. This is how much jobs went down. It didn't really go down that much. And they didn't tell you that the distance between this and this was 100,000. No. They don't tell you that, oh, that's a million. Let's change that to 100,000. They don't tell you that that's 100,000 jobs that went down. You know, that scale got switched up to 100,000, right? No. They don't want to tell you that because then you would understand it better. You see what I'm saying? Oh, it's there. It says right here. It says goes down by 1. Goes down by 1. And then over here in small print, in 100,000s. And it's so small you can't read it. Okay? This is how people lie with statistics. It's really easy. Democrats, Republicans. That's why when you get to look at the elections, the Democrats say one thing, the Republicans say another thing, right? They're telling you the opposite. That's an absolute. How can both people be true? Because they're lying with statistics. Both sides. Both sides. So, I mean, I'm just saying, you have to learn the math so you can determine, is this really what's going on? Oh, then now I know it's actually going down by 100,000 people. 100,000 jobs. That's actually significant. Right? If it's going down by 1 job, well, that's not that bad. If it's going down by 10,000 jobs, is that bad? I don't know. When you're talking about 300 million people, not that bad. If you're talking about 500,000 people, that's pretty bad. Right? So, it just all depends. It's all relative to the situation. Right? That's what's going on with this. It's relative to the situation. We changed the scale so that we could fit 80 pieces, right? That means that we had to squeeze this down. We actually compressed it. Does that make sense? And so we made this not look so coned and actually made it look like that. Okay? The 1 is still 1, but the 1 in relationship to the 10 is 1/10. So the scales are off, right? So it won't look, what do I want to say? Symmetrical, okay? But if you take a look at that, you'll be able to understand that this scale, okay, is 1/10 the scale of the other one. Okay? So if it's 1/10, that's why it's going down only in one way. Only horizontally, right? It's going down horizontally. It's not going down vertically, so therefore it's a horizontal compression just by changing the scale. Okay? So now we compressed that, and then we were able to show just how much this stretched. Because think about that. If we were to graph this at 20, just at 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That means this would go right? That's how much that's stretched. Does that make sense? And that's only from here to here. You see what I'm saying? That's a huge stretch. Because it was 20 times. Right? That's a big stretch. Better? Okay, good. Alright. Let's do this one. Alright, so if it's inside, what are we saying? Inside is what? Vertical or horizontal? Horizontal. Okay? Alright. So we know it's horizontal. And hors Lie. Okay? X's do the opposite. X's do the opposite. That's why they're your X's, right? Okay? What does that mean? If I were to put that in the equation, what did we have to do? We had to flip it. Good. We had to flip it. That means that this is really 3 over 1. Okay? If that's true, is that a stretch or is that a compression? Stretch. Why? It's bigger than 1. Say less. All right. So this is a stretch. Right? So it's a horizontal stretch of a factor of 3. Okay? A horizontal stretch with a factor of 3. Okay? Well, then we got to graph it, right? What does it change? Does it change the x or does it change the function? Or does it change both? It changes the x, right? But with changing the x, what happens to the function? It changes. That's why, remember when Ms. Markey was like, yeah, they both change. It's always a change. And with linear, she was like, it's the same change. And I was like, no, not always. Be careful, right? Because she knew that it wasn't the same all the time with this. It just wasn't. Because it's really easy to see. But it's not the same all the time with linear either. Remember we saw that when it did it second. Okay, when horizontal came after the vertical. Okay, so that was really important. This is just as important with this. Okay, so it changes your function. Right? It changes your function. It changes your x. So your new x, right? We're taking this x and we're multiplying it by what? 3. Okay? And that's going to give us our new j of x. Right? And your x was 2. So now it's going to be 6. Your x was 1. So now it's going to be... Your x is 0. So now it's going to be... Your x is -1, so now it's going to be... Your x is -2, so now it's going to be...